Number one, the following diagram shows a circle with center O and radius 4. This the circle. The points P, Q, and R lie on the circumference of the circle, and angle POR is theta. You can see on this circle. The theta is measured in radians. The length of arc PQR is 10 centimeters. So PQR 10 centimeters. Find the perimeter of the shaded sector. So the perimeter is PQR plus 4 plus 4. PQR is 10. This is 4. This is 4. So PQR 10 plus 4 plus 4. A, the perimeter equals 10 plus 4 plus 4, it is 18 centimeters. B, find theta. To find theta, we need to find the perimeter of circle. The perimeter of circle, the formula is 2 pi r. 2 multiply 22 over 7 times 4 centimeters. And if you calculate, the result is 25.143 centimeters. So this is the perimeter of circle. I'm going to show you. This is 10 centimeters, but the perimeter of circle, the perimeter of circle is 25.143. Okay, so difference. A perimeter of shaded area, this is 10 plus, this is 10, okay, plus 4 plus 4. But if perimeter circle is the perimeter of circle, the circumference of circle, right? As we continue, it means theta equal 10. 10 is length of PQR, this one, QR, because this is theta, so PQR divided by 360, it's 10, 10 divided by, no, not 360, but 25.143, 25.143, okay, multiply 360, because in degrees. So if you calculate, the result is 141.565 degrees. We are going to convert degrees into radians. It means 145.565 multiply 3.14 divided by 180. And it is 2.4695. Round off becomes 2.5 radians. Next. C. Find the area of the shaded sector. So we're going to find this area, the shaded sector. The shaded sector here. Firstly, we need to find area of circle pi r squared, or 22 over 7 multiply 4 squared, and it is 50.2857. And area of shaded sector, it equals 141.5 65 divided by 360. This is theta. Okay, this is theta. So theta divided by 360 multiply this area. 50.2857 and it equals 19.774. Round off becomes 20 centimeters squared because area. Number two, a function f is defined by fx equal 1 minus 1 over x minus 2, where x element of R and x not equal to. A, the graph of y equal fx has a vertical asymptote and horizontal asymptote. Write down the equations of vertical asymptote and the horizontal asymptote. The function is fx, or I would like to writing as y equal 1 minus 1 over x minus 2. Now the first, regarding the vertically asymptote. To find the vertically asymptote, we look for values x, this x. So this x is the denominator, is the part of the denominator x minus 2 of this fraction, of course. So we need to set this is become 0. Why? Because if 1 over 0, it is undefined. Okay. As you know that if y equal undefined, it means y-axis is the asymptote if y equal undefined. As well, if x equal undefined, so this x-axis will be the asymptote of a graph. Now we back to this function. So the vertical asymptote occurs where this denominator is equal 0. If this denominator equals 0, it means this part will be undefined, right? So x minus 2, it should be 0. If x minus 2 equals 0, so x equal 2. And this is the vertically asymptote. But second, horizontally asymptote. To find the horizontally asymptote, we need to consider that x, okay, that x should be approached to uh, positive unlimited or minus unlimited. If x approach to unlimited or minus unlimited, so this equation becomes y equal 1 minus 1 over unlimited minus 2, and it is equal 0. And if this is 0, if this is 0, it means y will be, if this is unlimited, sorry, if 1 over unlimited is 0. Okay. If this is unlimited, unlimited minus 2 is unlimited, so it becomes 1 minus 1 over unlimited. And this is 0, so it's going to be 1 minus 0. And it is 1. So horizontally asymptote is horizontally asymptote equation is y equal 1. This is the horizontally asymptote. 1. Next question. Find the coordinates of the point where the graph of y equal fx intersects the y-axis and the x-axis. Part B. To find the intersection on the y-axis, intersection on the y-axis, we need to set that x equals 0. If x equals 0, so the equation becomes y equal 1 minus 1 over 0 minus 2. And it is 1 minus 1 half. Becomes 1 plus 1 half or 3 half. So the coordinate point is 0, 3 half because x, y. Next, this is part 1. The intersection on the x-axis occurs when we set that y equals 0. Okay. If y equals 0, this equation becomes 1 minus 1 over x minus 2 equals 0. Okay, so it's going to be 1 over x minus 2 equals 1, like this. And if we calculate, multiply x minus 2 multiplied by 1, it's going to be x minus 2 equal 1. And it is x equal 2 plus 1, 3. So this is the horizontally asymptote equation. Okay, so this is sorry, not horizontally. This is the wrong coordinate point. Not horizontal. This is coordinate point. This is the coordinate point. 3, 0, x, y, 3, 0. This one. Intersection on the x-axis. 3, y, 2, 0. And next we're going to sketch on this diagram. Firstly, we need to find the asymptote. The first asymptote is x equal to this one. Create the strike line on this x equal to, okay, this is asymptote x equal 2. And the second asymptote is y equal 1. This is the asymptote y equal 1. And after that, the intersection point, the intersection between the graph and y-axis and the y-axis is on 0, 3 half here. This is 0, 3 half. And after that, intersection on x-axis, 3, 0 here. 3, 0. And after that, create the graph. Like this. Okay, this is asymptote for y-axis and x-axis. After that, here, asymptote for y-axis and asymptote for y equal 1 and x equal 2 as well. This one, x equal 2 and y equal 1. Number 3, Events A and B are such that P A or probability A equals 0.4, probability A given B, this conditional probability A given B, 0.25, and probability A union B is 0.55. Find the probability B, right? So the conditional probability B, conditional probability A given B, the formula is probability A intersection B over probability B. So we can rearrange this formula becomes probability A intersection B equal probability B multiply the conditional probability A given B. Okay, in probability lesson, so we have the formula that the probability of A union B, the formula is probability A plus probability B minus probability A intersection B. Now I will substitute this probability A intersection B, this term or this expression into here. So it becomes probability A plus probability B minus probability B times the conditional probability A A given B. One. Okay. And then after that substitute, probability A is 0.4. Probability B, we're going to find probability B. A union B, this one, 0.55 minus probability B. This probability A given B, 0.25. And it becomes 0.55 minus 0.4. 1 probability B minus 0.25 probability B is 0.75 probability B times probability B. And this is 0.55 minus 0.4 is 0.15. Yeah. 0.75 probability B. So probability B equals 0.15 over 0.75. And it is 1/5 or 0.2. Number 4, the following diagram shows part of the graph of y equal x over x squared plus 2 for x greater than or equal 0. This is the diagram. The shaded region R is bounded by the curve, the x-axis, and the line x equals c. The area of R is ln 3, so this area is ln 3. Find the value of c. That area is integral of 0 to c of fx. Fx is x over x squared plus 2 dx. And according to the information that this area is ln 3, according to this information. Next, I will find the integral of this function first. So let u equal x squared plus 2. So du equal 2x dx. 1/2 du equal x dx. So it means this integral we can writing as area equal 0 to c 1/2, okay, and x dx is 1/2 du. So du over u, like this. Now, I will change this becomes function uh, x equal x equals 0 and x equals c. At x equals 0, it means u0 will be 0 squared plus 2, and it is 2. Because u is this one, u function x squared plus 2. Okay. At x equals c, u c equal c squared plus 2. So I would like to change 0 becomes 2 and c becomes c squared plus 2. And the integral of du over u is ln u. So it's 1/2 integral. This is 2 and this is c squared plus 2. And the integral is ln u. And after that, substitute c squared plus 2 and 2 into ln u. It's going to be ln c squared plus 2 minus ln 2, 1. It becomes 1/2 ln c squared plus 2 over 2, like this. And according to the information that this is equal ln 3. So we can rearrange becomes ln c squared plus 2 over 2 equal ln 3, 2 ln 3. Okay, because 1/2, because this is multiplied by 2. If multiplied by 2 becomes like this. And 2 ln 3 becomes ln 3 squared according to the ln rule. Ln 3 squared or ln 9. Ln 9, like this. So it means we can state that c squared plus 2 over 2 equal 9. And if 2 multiplied by 9, it becomes or multiply by 2. This expression multiplied by 2, this expression 9 as well multiplied by 2, is going to be c squared plus 2 equal 18. Or c squared equal 18 minus 2 equals 16. And c equals square root 16. It is 4. So c equal 4. Number 5. The function f and g are defined for x element r by fx equal ax plus b, gx equal x squared plus x plus 3. So this is fx and this is gx. There are two functions. Find two possible values. Find two possible function f such that g of fx equal 4x squared plus 14x plus 15. Right. So I would like to simplify first, or writing g of f of x becomes like this: g of f of x. It is 4x squared minus 14x plus 15. This is gx and this is fx. So if gfx, it means we can writing that 4, 4. I will expand this. Okay. fx and gx. Okay. Gx is x squared plus x plus 3. If g of fx, it becomes f x squared plus fx plus 3. If fx equal ax plus b, so it is ax plus b squared plus ax plus b plus 3. 1. So if we expand, it becomes a squared x squared plus 2abx, okay, plus 2abx plus b squared plus ax plus b plus 3. So it becomes a squared x squared factorize 2ab plus 2ab plus a x plus b squared plus b plus 3. So this is g of f of x. And it equal, according to this information, that g of f of x as well equal 4x squared minus 14x plus 15. So now look that this expression is equivalent with this expression. So a squared x squared equal 4x squared. So it means a squared equal 4. And a equals square root 4. It is positive and negative 2. Now, if a equal positive 2, so substitute into this this expression, one. So it's gonna be 2 times b plus 2. And according to information that this expression equivalent with this expression minus 14. So 4b plus 2 equals minus 14. 4b equal minus 16, and b equal minus 16 divided by 4 equals minus 4. 1. Now, if x equals minus, if a equal minus 2, so it becomes 2 times minus 2, b plus minus 2 equal minus 14. Minus 4b minus 2 equal minus 14. Minus 4b equal minus 12 because minus 14 plus 2, and b equal 3 because minus 12 divided by minus 4. Right, if we substitute b, okay, if b minus 4 substitute into this expression, minus 4, if this is 16, minus 4 is 16, minus 4 is 12, 12 plus 3 is 15 equals 15. So prove that this statement is correct. How about if b equals 3? If b equals 3, it means this is 9 plus 6. 9 plus 9 plus 3, sorry, 9 plus 3 is 12, 12 plus 3 is 15, so correct. So b equal minus 4 and b equal 3 are correct for this statement. And the next, if a equal 2, b equal minus 4, so fx ax plus b, so the function will be fx equal 2x minus 4. And if a equal minus 2 and b equals 3, this one, or 3, so fx equal minus 2x plus 3. So there are two possibilities, functions 1 and this one. Okay. This one and this one. Continuous random variable x has probability density function, PDF, defined by this function, where a is a positive real number. State expectation x in terms of a. Fx equal 1 over 2a according to this information. Okay, for x interval a to 3a. So Ex equal integral a to 3a of x times 1 over 2a dx. It is 1 over 2a integral, because 1 over 2a is constant, a to 3a x dx. 1 to a, 3a, integral of x is 1/2 x squared. So it becomes 1/2 1 over 2a. Okay, after that, substitute 3a and a. becomes 1/2 3a squared minus 1/2 a squared 1 over 2a. This is 9. 9 over 2a squared minus 1/2 a squared. Now multiply becomes 9/4 a squared over a minus 1/4 a squared over a this is 9 minus 1 over 4 a squared over a or a over a 2a. So the expectation x is 2a. Use integration to find variant x in terms of a. Variance x is ex squared minus ex squared. So we need to find this one, ex squared is ex, already this one to a, ex squared equal integral from a to 3a of x squared 1 over 2a dx. 1 over 2a integral a to 3a. The integral of x squared 1/3 x cubed. After that, substitute 3a and 2a and a, I mean 1 over 2a times 1/3 3a cubed minus 1/3 a cubed 1 over 2a. This is 27 divided by 3, 9 a cubed 1/3 a cubed 1 over 2a times this is 27 minus 1, 26 third a cubed. So it becomes 26 over 2 a cubed divided by a squared. Means third, so this one, 3, 6, because 3 times 2. So it becomes 13 third, because divided by 2, 13 third a squared. This is ex squared. So variance, we can determine variance x is ex squared is 1, 13 third a squared minus 2a. It's 1, so 2a squared, sorry, according to this formula. So 13 third a squared minus 4a squared. 13 third a squared minus 3 times 4, 12 third a squared. 13 minus 12, 1. 1/3 a squared or a squared third. It's 1. Number 7, use mathematical induction to prove that sigma r equal 1 to n of r over r plus 1 factorial equal 1 minus 1 over n plus 1 factorial for all integers n greater than 1. So the first step to prove with mathematical induction, if n equal 1, for left-hand side is 1, becomes sigma r equal 1 to n. So n over n plus 1 factorials. 1 over 1 plus 1 factorials, 1 over 2. Right-hand side. Right-hand side, 1 minus 1 over 1 plus 1 factorials. This is right-hand side. So it's equal 1 minus 1 half. 1 half. So left-hand side and right-hand side are equal. The second step. The second step is inductive step. We assume that n equal k. So it means that in sigma r equal 1 to k r over r plus 1 factorials. It is 1 minus k plus 1 factorials. Okay. So we need to prove that the statement holds for n equal k plus 1. So we need to show that sigma r minus 1 to k plus 1, because n equal k plus 1, r over r plus 1 factorials equal 1 minus 1 over k plus 1, k plus 1 plus 1, it means k plus 2 factorials. And I would like to break down the left-hand side. Okay. Scroll down first. It becomes like this. Sigma r equal 1 to k plus 1 r plus 1 factorials equal sigma r equal 1 to k r over r plus 1 factorials plus k plus 1 over k plus 2 factorials. It becomes 1 minus 1 over k plus 1 factorials plus k plus 1 over k plus 2 factorials. This equal, I would like to write it here. 1 becomes k plus 2 factorials over k plus 2 factorials. 1 over k plus 1 factorials plus k plus 1 over k plus 2 factorials. And we're going to set become the same denominator. K plus 2 factorials over k plus 2 factorials plus k plus 1, k plus 2, sorry, over multiply with k plus 2 becomes k plus 2 factorials, k plus 1 over k plus 2 factorials. So it's going to be, this is supposed to be minus okay, k plus 2 factorials minus k minus 2 plus k plus 1. K plus 2 factorials. So k plus 2 factorials minus 1 over k plus 2 factorials. So it becomes k plus 2 factorials over k plus 2 factorials minus 1 over k plus 2 factorials, or 1 minus 1 over k plus 2 factorials. So we can state that sigma r equal 1 to k plus 1 of r over r plus 1 factorials equal 1 minus 1 over k plus 2 factorials, okay, or equal 1 minus 1 over k plus 1 plus 1 factorials. If we compare with the previous solution, so we can state that, I would like to write in here the solution, the statement. So P k plus 1 is true whenever pk pk is true and p1 is true. So pn is true for all integers n greater than 1 by the principle of mathematical induction. We have proven that sigma r equal 1 to n of r over r plus 1 factorials equal 1 minus 1 over n plus 1 factorials for all integers n greater than 1. So number 8. The functions f and g are defined by fx equal cosine x, gx equal tangent x, which x interval 0 to pi half. The curve y equal fx and y equal gx intersect at point P, whose x coordinate is k, where k interval 0 to pi half. Show that cosine squared k equals sine k. Okay. To find the intersect point at P with x equal k, according to information, we need to set that fk equal gk. So it means cosine k equal tangent k, because fx is cosine x, gx is tangent x. So cosine k equals sine k over cosine k. If we multiply left-hand side, right-hand side with cosine k, it becomes cosine squared k equal sine k. So this is the first equation, part B. Hence, show that the tangent to the curve y equal fx at P and the tangent to the curve y equal gx at P intersect at right angles. Intersect at the right angle. So we need to find the derivative of fk and gk. Fk is cosine k. So derivative fk equal minus sine k. Gk is tangent k, and the derivative of gk is secant squared k, or 1 plus tangent squared k. For the tangents to the intersect at right angles, the product of their slopes must be minus 1, because if two straight lines are perpendicular each other, their slopes m1 times m2 should be minus 1 if perpendicular, right? So it means derivative k minus derivative g should be minus 1. Okay, minus sine k, because a slope or gradient is derivative of the function. Secant squared k to minus 1 minus sine k times 1 over cosine squared k equal minus 1. Okay, after that is multiply. Multiply with cosine squared k. So it becomes minus sine k equal minus cosine squared k divided by minus 1 becomes cosine squared k equal sine k. Okay. This is the second equation. Now, if we compare with the first equation, this one, so first equation and second equation, uh, yeah, is equal. So the conclusion, we can state that this equation this equation, the second equation matches with the first equation Uh, on part A, it means it's showing that the tangent at PK intersect at right angle. Sure. Next question. Find the value of sine k. Give your answer in the form a plus square root b over c, where a c element integer and b element integer positive. On part A and part B, we got the equation cosine per k equals sine k. So 1 minus sine square k equals sine k. Cosine square k equal this one minus sine k. Or this equation becomes sine square k plus sine k minus 1 equals 0. Let x equal sine k. So this equation becomes x squared plus x minus 1 equals 0. So a equal 1, b equal 1, c equal minus 1. I'd like to using ABC formula to determine the value of sine. Minus 1 plus minus square root 1 squared minus 4 times 1 times minus 1 divided by 2 minus 1, 2 times 1. And it is minus 1 plus minus square root 1 plus 4, 5, 2. Okay, so x1 is minus 1 minus square root 5 over 2, and x2 is 1 minus 1 plus square root 5 plus 2. Okay, since the interval of k 0 to pi half, so we are not using this result because this result is negative number. So we are going to using this result. So it means the conclusion sine k equal minus 1 plus square root 5 over 2. Number 9. The following diagram shows parallelogram OABC with factor OA is A, factor OC equals C, and modulus C equal to modulus A, where modulus A not equal 0. This is the parallelogram. The angle between factor OA and factor OC is theta. This is theta, where theta greater than 0, less than pi. Point M is on line AB, such that factor AM equal K factor AB, where K interval 0 to 1 and 0 factor OM dot factor MC equals 0. This is orthogonal. Yeah, it's equals 0. Express OM and MC in terms of A and C. Factor OM and factor AC in terms of A and C. OA, vector OA equal vector CB. It is A. Let's see the vector OA, OA, CB. It equal A. It means if BC minus OA. Vector OC equal vector AB. It is C. Vector AM, AM, AM is OA plus AM. Yeah, oh, that's OM. Sorry, I mean AM. AM is, according to the information, that AM is KAB. AB is C. So K times C, KC. Yeah. So AM, AB, AB is C. It is KC. MB, vector MB is 1 minus KC. MB is 1. MB is 1. This is 1. A to B is 1. 1 minus AM minus K and times C. Right. And OM. OM, OA plus AM. You can evaluate the parallelogram. OA is A, AM, KC. MC, no MC. Vector MC is MB plus BC, vector BC. I'm going to show you. MB is 1 minus KC, and BC is opposite of OA, opposite of CB. It means this is minus A. So MC equal MB. MB is 1 minus KC minus A. So OM and MC. B. Hence, use a vector method to show that A squared times 1 minus 2k times 2 cosine theta minus 1 minus 2k equals 0. This expression is equal 0. Okay, I'm going to listen like this, or M dot MC. It is A plus KC dot 1 minus KC double brackets minus A. So equals 0 because OM, according to the information, that OM dot MC equals 0. And we are going to describe, okay, expand this. A, wait, I would like to bring this one in brackets first. 1 times C1, C, KC minus A equals 0. After that, multiply AC and then minus AKC and then minus modulus A squared plus KC. K plus C minus 1 K squared. C squared minus A ACK, like this, equals 0. And it becomes AC 2, because there are two AKC, this one and this one. One and this one, minus ACK, A squared plus KC squared, this one, minus K squared C squared equals 0. And I would like to factorize 1 minus 2K AC. This one and this one. A squared. K factorized as well. 1 minus K C squared equals 0. According to the information that modulus C equal 2 modulus A, and AC equal 2 modulus A squared cos theta. Now substitute this information into this equation. So this equation becomes 1 minus 2K 2 A squared cosine theta, because AC equals 1, minus A squared plus K 1 minus K 1 minus K, this one is 2A, this one 2A squared, 0. And after that I will factorize this one and this one, becomes 2 1 minus 2K, and then A squared cosine theta. No need this. A squared plus, this is 4A squared. It means times K becomes 4K 1 minus K A squared equals 0. Comes 2 1 minus 2K A squared cosine theta minus, if we set this becomes, I would like to factorize like this, A squared times 4 times this one, 1, and 4 times K squared times K, it becomes 4K squared. So 1 plus 4K minus 4K squared. Okay, so 1, if 4K times 1, 4K, and 4K times K is 4K squared. 1 because we factorize this one. Let's continue. So it's going to be 2 times 1 minus 2K A squared cosine theta minus 1 minus 2k. Factorize this square. If you expand this, becomes 1 plus 4k minus 4k squared. Okay, and after that, factorize again. It becomes, if factorize a times 1 minus 2k, 2 cosine theta, 2 cosine theta minus this a already here, 1 minus 2k squared equals 0, or modulus a squared. Factorize again, 1 minus 2k times 1, 2 cosine theta minus 1 minus 2k equals 0. So prove that this expression equals 0 according to this statement. This one. C. Find the range of values for theta such that there are two possible positions for m. C. Cosine squared k. Wait. So cosine squared. I mean, first, I would like to rewrite again the equation of cosine. This one, 1 minus 2k, 2 cosine theta minus 1 minus 2k equals 0. And if we divide by modulus a squared, becomes 1 minus 2k, 2 cosine theta minus 1 minus 2k equals 0. So there are two possibilities of solution, that 1 minus 2k equals 0, or 2 cosine theta minus 1 minus 2k equals 0. This. So this left-hand side, 2k equal 1, k equal 1 half. For this one, so we are not using this solution. Now this one, 2 cosine theta minus 1 plus 2k equals 0. So 2k equal 1 minus 2 cosine theta. Yeah, correct, like this. So k equal 1 half minus cosine theta. Now we are going to using this solution. K equal 1 half minus cosine theta. Let's continue. For real values of theta, cosine theta, okay, this cosine theta must lie in the range of cosine theta must lie in the range of 0 and 1. So that's why k interval 0 to 1. K is 1, it means we can substitute, this value into this k. 1/2 minus cosine theta 0 to 1, like this. And after that, minus 1/2. If 0 minus 1 becomes 0 minus 1/2, this becomes minus cosine theta 1 minus 1/2. It becomes minus 1/2 theta 1/2. After that, times minus 1. If times minus 1 becomes 1/2 cosine theta minus 1/2, or cosine theta minus 1/2, 1/2, like this. So we can state that the interval, I would like to continue here, the interval, interval of cosine theta between minus 1/2 and 1/2. Minus 1/2 is cosine. Minus 1/2 is cosine 2 pi third, and 1/2 is cosine pi third. So it means theta interval from pi third to 2 pi third. This from pi third to 2 pi third. Number 10, a circle with equation x squared plus y squared equal 9 has center 0, and radius 3. A triangle PQR is inscribed in the circle with its vertices at P minus 3, 0, Q, x, y, and R, x, minus y, where Q and R are variable points in the first and fourth quadrants, respectively. This is shown in the following diagram. Okay. So this is Q in the first, this is the first diagram, the first quadrant, the second quadrant here, the third quadrant here, and the fourth quadrant here. First, second, third, and fourth quadrant. For point Q, show that y equal 9, y equals square root 9 minus x squared. The equation of circle is x squared plus y squared equal 9. So y squared equal 9 minus x squared. So y equals square root 9 minus x squared. Proved. Hence, find an expression for A, the area of triangle PQR in terms of x. Expression for area. So area of triangle is equal 1/2 times base times height. Okay, this is the formula. So we need to find first the base. So base is the distance between Q and R. So between Q and R. The distance between Q and R is the base. And the distance is not x and x, but y and minus y. distance between y and minus y is y minus y. It is 2y because y plus y. So base equal 2y. Next, the height is, I'm going to show you, between this point is x, okay, because this strike line on x, on point x, and this point. This point is minus 3,0. It means height is the distance between minus 3 and x. So it means x minus 3 or x plus 3. So this is the height. The height is x, x plus 3. For base, I would like to substitute y into this equation becomes 2 times square root 9 minus x squared. So this is base, this is height. So area of triangle equal 1/2 times 2 square root 9 minus x squared times x plus 3 equal 1. And it is x plus 3 times square root 9 minus x squared. So this is area in x. Question C. Show that the derivative of A is this expression. Okay. So derivative of A, I would like to using this formula for derivative. That okay, let u equal x plus 3. It means du equal 1. Okay, du dx equal 1. V equal square root 9 minus x squared or 9 minus x squared power 1/2. Power 1/2, sorry, not minus 1/2, but power 1/2. Because square root. So the v dx is 1/2 times 9 minus x squared power minus 1/2 times derivative of minus x squared is minus 2x. And it is this one divided. So becomes minus x, 9 minus x squared power minus 1/2, or becomes minus x times 1 over 9 minus x squared or 1/2, and becomes minus x over square root 9 minus x. So the x we can gain from u times the phi dx plus phi times du dx. U is 1x plus 3. The phi dx is 1 minus x over square root 9 minus x squared. Sorry, x squared actually. plus phi is this what phi, this one. Square root 9 minus x squared du dx 1. So it's going to be, sorry. So it becomes, we calculate, becomes minus x times x plus 3 over square root 9 minus x squared plus I would like to set becomes the same denominator 9 minus x squared. It means here is 9 plus x squared multiply minus x squared minus 3 plus 9 plus x squared. Okay. Minus x squared, I mean. This is minus x squared. Okay. Over square root 9 minus x squared. And becomes minus 2x squared minus 3 plus 9. Oh, this is minus 3x, sorry. Minus 3x actually, this one. Minus 3x plus 9 divided by square root 9 minus x squared, that one. So let me evaluate the question. Oh, same. So prove that the ADX equal this expression. Last question. Hence or otherwise, find y coordinate of R such that A is a maximum. R is, y coordinate is minus. Okay. Okay, maximum of a function we can gain if the first derivative equals 0, if the x equal 0 for maximum. Okay, so it means this function, this expression should be 0 minus 2x squared minus 3x plus 9 over square root 9 minus x squared equals 0. And if you calculate, if you multiply with square root 9 minus x squared, it will be minus 2x squared minus 3x plus 9 equals 0. So I would like to find x1 and x2 using ABC formula. So it means A equals minus 2, P equals minus 3, and C equals 9. ABC formula. So x1 and x2 is minus of minus 3. It means positive 3 plus minus square root of minus 3 squared minus 4 times minus 2 times 9 over 2 times minus 2. It becomes 3 plus minus square root 81 because, oh, square root 9, sorry, not 81, 9. It's squared. And it is 9 plus 72 over minus 4. 3 plus minus 81 over minus 4. 3 plus minus 9 over minus 4. So x1, x1 is 3 plus 9 over minus 4. It is 12 over minus 4 and is 3. While x2 equal 3 minus 9 over minus 4. And it is minus 6, minus 2, minus 4, sorry, minus 4. And simplify becomes 3 half. Okay. So there are 2x minus 3 and minus and positive 3 half. Let's look. X value here, x is positive, not minus. So we have to take the positive result 3 halves. Do not take this one minus because this is minus. We need to take this one, the positive result 3 halves. So x equals 3 half. If x equals 3 half, substitute into y equals square root 9 minus x squared, because we are going to find the value of y. So it's going to be y equals square root 9 minus 3 half squared. 9 minus 9 over 4 is square root 4 times 9, 36. 36 over 4, 9 over 4. Square root 27 over 4. Or it is square root 27, square root 4 is 2. Square root 27 is square root 9, square root 3. Divided by 2. So 3 square root 3 over 2. Okay. So it's 1. Yeah. Y is 1. Or we can state that the y, the r coordinate, okay, r coordinate is x comma minus y. So this means that r coordinate is, wait, scroll down, okay. The x, okay, x is 3 half, x 3 half, 3 half, comma minus 1 minus 3 square root 3 half. This is the coordinate point of r. And y coordinate, according to the question, y coordinate is minus 3 square root 3 half. This is the y coordinate, this one. Number 11, consider the complex number u equal minus 1 plus square root 3i. A, By finding the modulus and argument of u, show that u equal to e power I to pi 3 to pi third. Okay, finding the modulus and argument. So modulus of u is square root a squared plus b squared. It is minus 1 squared plus square root 3 squared. 1 plus 3 square root 4 is 2. The argument of theta of the complex number u can be found using this one, theta equal tangent or arctangent theta. Theta equal arctangent b over a. Tangent for minus 1, root 3 minus 1. It is, yeah, tangent this one, or tangent, yeah, okay, until this one, tangent square root minus square root 3. Sorry. Yeah. Yeah. Okay. Uh, the tangent of pi third, tangent of pi third, tangent of pi third, the result is square root 3. That is tangent pi third. So the reference angle is pi third. Okay, pi third 180 over 3 is 60. Okay, but since the complex number lies in the second quadrant because in trigonometry there are the first quadrant, second quadrant, the third quadrant, and the fourth quadrant. The first quadrant from 0 to pi half, and the second quadrant pi half to 182 pi. Okay, so it's from 0 to uh, pi, right? So the argument, you can state that the argument theta equal pi minus pi third, and it is 2 pi third because 3 times, because 3 is 3 over 3 minus 1 over 3 equal 2 over 3. So we can express in polar form as u equal 2 times cosine 2 pi third plus I sine 2 pi third. And using Euler's formula, it becomes 2 e power I 2 pi third, like this. Because according to Euler's formula, that if cosine theta plus I sine theta, it is e power I theta, like this. So if cosine 2 pi third plus I sine 2 pi third, we can writing this as e power I 2 pi third, like this. So that's why u equal to e power I 2 pi third. Next question, D. Find the smallest positive integer n such that u power n is a real number. Find the value of u power n when n takes the value found in part B1. B. From part A, we got u equal to e power I to pi third, like this. So it means u power n becomes 2 e power I to pi third over n. And it becomes 2 power n e power I n to pi third, like this. So for u power n to be a real number, the angle 2 pi, the angle 2 pi third n, it must be the multiple of pi, multiple of pi, must be multiple of pi. So it means 2 pi n 2 pi third equal k times pi, because multiple of pi for integer, for k is integer. K is integer, right? So it means n we can state as k pi times 3 over 2 pi, like this, right? So it becomes 3k half, like this. And k must be k must be the integer even number. K must be uh, the even number. Why? Because if k integer and divided by 2, so k must be the even number, cannot odd number. Because if odd number, it becomes the fraction, or decimal number. So n equal 3k half. If even number, so k equal to m, which m is integer. M integer, or m element z. Okay. So it becomes 3 times m times 2m over 2, right? It becomes 3m. And m must be for the value of n, the smallest value of n, m should be equal 1, the integer positive. So n becomes 3 times 1, and it is 3. So the smallest positive integers occurs when n equal 1. Next, part 2. Un equal 2 power n e I n 2 pi third. This is 3, right? Or 2 power n cosine cosine n, sorry, 2 pi third, okay, so, no, e, cosine 2 pi third n plus I sine 2 pi third n, like this. So it means if u third, it is 2 cube, sorry, 2 cube is 8. Cosine n equals 3, it means 3 divided by 3 becomes 2. I sine as well 2 pi, like this. It's going to be 8. Cosine 2 pi is 1 plus I times 0. Sine 2 pi is 0. So it is 8 times 1, 8. So u third is 8. Next question. Consider the equation c cubed plus 5c squared plus 10c plus 12 equals 0. Given that u is a root of c cubed plus 5c squared plus 10c plus 12 equals 0, find the other roots. By using a switchable transformation from z to w or otherwise, find the roots of the equations 1 plus 5w plus 10w squared plus 12w cubed equals 0. Okay. Let's see. The equation c cubed plus 5c squared plus 10z plus 12 equals 0. According to the information that it has roots, one of these root is u equal minus 1 plus square root 3i. Right. So if this equation has 3 roots because this is cube equation, so the roots are z minus u, z minus first root, and z minus the second root equals 0 because this is actually the second root and this is the third root. So the first root is 1, right? For the polynomial has real coefficient, the non-real roots must occur in conjugate pairs. So the conjugate of u, so the conjugate of u, I would like to write in as the place similar like this. The conjugate of u, it is minus 1 minus square root 3i. So on. So this is the second root. So the first root is this one, and the second root is the conjugate of u is minus 1 minus square root 3i. Next, by Vieta's formula, the sum of the roots is given by the coefficients of c squared. That is according to Vieta formula. So this is the coefficients of c squared. So we can state that the first root plus the second root plus the third root it equals minus 5 because according to the Vieta's formula, that the sum of the roots is given by coefficients of c squared and the opposite sign. That's according to uh, Vieta formula. Okay. This is u, and this is the conjugate of u, and this is r, the third r, the third roots, I mean, conjugate, that's 5. Now, I would like to substitute -1 plus square root 3i is -1 minus square root 3i plus r third equal -5. So it is 0. -1 -1 -2 plus r third equal -5. Okay, so the third root is -5 plus 2 equal -3. This is the third root. Second, let's make the transformation w equal 1 over c. Then z equal 1 over w. This is the transformation we are going to use. So it means, I will scroll down first. So c cube equal 1 over w cube, and c square equal 1 over w squared if z is 1. So this is c squared, this is c cube. The roots of this equation, c cube plus 5c squared plus 10c plus 12 equals 0 are the roots. Okay, the roots of these equations are z1 is -1 plus square root 3i, z2 is -1 minus square root 3i, and z3 equal -3. We got this result on the previous equation, so and solution, right? So the roots of 1 plus 5w plus 10w squared plus 12w cubed equals 0 are w1, the first w. The first w, based on this transformation, so it becomes 1 over z. So 1 over z1. 1 over z1 is 1 over -1 plus square root 3i, like this. So I would like to multiply with -1 minus square root 3i minus 1 minus square root 3i, the conjugate of this denominator. So it becomes -1 minus square root 3i over -1 squared. Okay, this is supposed to be minus, but I multiply I is -1 becomes plus 3. So it becomes -1 minus square root 3 I over 4. That is for the first W, the first root. And the second root is second W. The second W, 1 over C2, the C2 is 1, 1 over -1 minus square root 3 I. So multiply with this conjugate, -1 plus square root 3 I over -1 plus square root 3 I. And it is similar to this one, but it becomes -1 plus square root 3 I over 4. First root, second root, and the third root is W3. It is 1 over C 3. This one minus 1/3. So the first, the second, and the third root. Next question. Consider the equations of c squared equal 2c conjugate of c, this is the symbol. Okay, where c element c not equal 0. By expressing z in the form of a plus bi, find the roots of the equation. Here. D. I'm going to express z in the form of z equal a plus bi. And the complex conjugate z equal a minus bi. This is the conjugate of this one, of z. So it means if c squared equal 2 conjugate c becomes a plus b I equal 2 times a minus b I, like this, the square. And after that, I would like to expand this to a b I becomes minus because I squared is minus b squared equals 2a minus 2bi. That is so a squared minus b squared plus 2abi equal to a minus 2bi. Oh, next. This is the imaginary part. This is the imaginary part. So 2abi, wait, I need to write in the information. Imaginary part for imaginary part. Imaginary part is 2ab equal minus 2b. If we divide by 2b, we're gonna have the result of a equal minus 1. This is for complex root, right? And for the real part, a squared minus b squared equal to a. I'm gonna show you. This one equal this one. Okay, the real parts. Real parts. Right. So substitute minus 1 squared plus minus b squared equal minus 2 because substitute minus 1 here, a. So 1 minus b squared equal minus 2. So b squared equal minus 2 minus 1. Sorry, b squared 2 plus 1, 3. So b equal plus minus square root 3. Right. And this is the complex root as well. Right. Now, if we are going to have assume that b equals 0, why b equals 0? Because on this part, wait, I will write here that b should be 0. Why? Because c equal a plus pi, because if we are going to find a real number, we cannot involve b, because b is the part of imaginary part. Okay, b is the coefficient of imaginary part. So that's why b should be 0. If b equals 0, so we can substitute into this equation a squared minus b squared equal to a becomes a squared minus 0 equal 2a. So a squared minus 2a equals 0, and factorize a minus 2 equals 0. So there are two possibilities of a equals 0 and a equal 2. But we are not using a equals 0. Discard a equals 0. Why? Because according to the information that c cannot be 0, the roots cannot be 0. This one. So discard a equal 0. So a equal 2. This is the real root. So when b equals 0, the possible value for c, the possible value for z are c equals 0, but discard c equals 0, uh, c equals 0, and c equal 2. So we are going to discard this one, not using this one, and this is uh, the possible value for c. So the conclusion, the roots of z, this equation z equal to conjugate cr, scroll down first, I need more space. So c equal, the roots are minus 1 plus square root 3i, and the second is minus 1 minus square root 3i, and the third one is z equal 2. Number 12, by using an appropriate substitution, show that this integral cosine square x dx equal 2 square x sine square x plus 2 cosine square x plus c. The following diagram shows part of the curve y equals x for x greater than 0. Okay, but we are going to prove this equation first. Uh, let t equals square root x. Okay. If t equals square root x, it means t squared equals x, because square of square root x is x. So it means the derivative of t squared is 2t dt, and derivative of x is 1 dx. Integral cosine square x dx, it means it becomes 2, okay, 2t dt, 2 integral t cosine t dt, because dx equals 2t dt. By integration by parts, if integration by parts, we are going to using substitution u equal to t. It means du equal to dt. And phi, dphi equal cosine t dt. So this is u and this one dphi. Okay. So phi equal integral cosine t dt. It is sine t, okay, plus c. So integral, I'm going to writing 2 inside the integral dt. Its integral equal according to integration by parts. We can write thing as 2t sine t minus 2 integral sine t dt comes to t sine t minus integral sine is minus cosine, so it becomes plus because minus cosine. 2 cosine t, 2 cosine t, 2 cosine t plus c. And the next step, substitution, t equals 1. T equals square root x. So integral cosine square root x dx equal 2 square root x sine square root x plus 2 cosine square root x plus c. So on. Next question B. The following diagram shows part of the curve y equal cosine for x greater than 0. It's a diagram. The curve intersects at the x-axis, okay, x1, x2, x3, and x4. The x-intercept of the curve xn is given by xn to n minus 1 squared pi squared over 4. Write down the similar expression for xn plus 1. If this is xn, so we are going to find the expression, the equations is xn plus 1. So xn different with xn plus 1. Part B. The x-intercept, the x-intercept on x-axis of this curve y equal cosine square root x is given by xn to n minus 1 squared pi squared over 4. It means if xn plus 1 becomes 2 times n plus 1 minus 1. Okay, divided by 2. Oh, sorry. Pi squared. So it becomes, this is squared, it becomes 2n plus 1 squared because 2 times 1 minus 1, okay, becomes this one. Or the square is supposed to be here. Sorry. Okay, this one. Pi squared divided by 4. Okay. This is x n plus 1. Next question. The regions bounded by the curve and the x-axis are denoted by R1, R2, and R3 as shown on the above diagram. R1, R2, and R3. Calculate the area of region Rn. Okay. Give your answer in the form Kn pi, where K is element of integer positive, right? C, area of Rn. Area cannot minus, it should be positive. So that's why I would like uh, to calculate area as the positive result. Okay, modulus. So modulus of if modulus, it means never negative the result. So xn to xn plus 1 of cosine square root x dx. And we are going to calculate, we are going to find that integral of cosine square root x, the area, is n plus 1. The integral of cosine square root x based on part A is 2 square root x sine square root x plus 2 cosine square root x. This one. So I will factorize 2 on outside and then substitute xn plus 1 and xn into this expression. So it becomes 2n plus 1 pi over 2 sine 2n plus 1 pi over 2 plus cosine 2n plus 1 pi over 2 minus, okay, after xn plus 1, now xn. If xn is minus, so it becomes 2n minus 1 by half sine 2n minus 1 by half plus cosine 2n minus 1 by half. So different between xn plus 1 and xn. If xn plus 1, 2n plus 1, and xn is 2n minus 1. Right. So I would like to, before we continue, I would like to evaluate, okay, we are going to evaluate the sine and cosine values for multiplies of pi half. Okay. The sine and cosine. Values for multiplies of pi half. Okay. First, for sine 2n plus 1 pi half. Okay, this is pi half. The result is minus 1 power n. The second, we'll scroll down first. Okay, the second, cosine 2n plus 1 times pi half. Okay, the result is 0. The third, for sine 2n minus 1 pi half, the result is minus 1 power n plus 1. The fourth, for cosine 2n minus 1 pi half, it is 0. Substitute this information into this expression or this equation. So we can write A equal to times 2n plus 1 pi half times 1 minus 1 power n plus 0 minus 2n minus 1 pi half times minus 1 n plus 1 power n plus 1 plus 0, 1. And yeah, it becomes 0, it is 0, 2. After that, I would like to write 2n plus 1 by half minus 1 power n minus this is 2n minus 1 by half minus 1 power n times minus 1 because minus 1 power 1 is minus 1. So it becomes positive. 2 2n plus 1 pi half n plus 2n minus 1 pi half minus 1 power n becomes positive because minus times minus. And the next step, I would like to factorize minus 1 power n times 2n plus 1 times pi half plus 2n minus 1 times pi half. This. So area equal 2 times minus 1 power n 2n pi minus pi plus 2n pi. And this is, sorry, plus 1 because it's plus. Minus pi over 2. So 2 minus 1 power n. It is 0. So 4nr divided by 2 becomes 4 n, not nr, n pi, I mean. Yeah, divided by 2, and then after that, 4 divided by 2 becomes 2, this one. Because 4 divided by 2 equal to 2 n pi. So it is 2 times 2 becomes 4 n pi, because 4 minus 1 power n equal 1. This. So the area is 4 n pi. The next question. And show that the areas of the regions bounded by the curve and the x-axis R1, R2, and R3 form an arithmetic sequence. Arithmetic sequence. Okay. So if the constant difference of arithmetic sequence is D is the difference. Okay, the difference, it means if difference in arithmetic sequence, this is a constant. Okay, so the difference, constant, it means without variable. So we can state that D equal R n plus 1 minus R n. And Rn plus 1, according to our result from the previous question, this is 4n plus 1. This is Rn. Rn is 4n pi. So it means if n plus 1 becomes 4n plus 1, okay, pi, minus 4n pi. And if we calculate for n plus 4 for n pi plus 4 pi minus 4n pi plus 0, so D equal 4 pi. And 4 pi is a constant. So we can take the conclusion according to this result that difference is a constant for pi, and the arithmetic sequence R1, R2, R3, so on. So the conclusion, the areas of the regions the areas of the region, the areas of the region bounded by the areas of the regions bounded by the curve and the axis okay, the axis is the x-axis. It form an arithmetic sequence. That is the conclusion.